Okay, great. So, yeah, I'm just going to start. There's not a huge amount of people here, but today we're going to. So, first of all, I just want to introduce myself. My name is Eoin, and I work in the developer relations team of Edge Impulse, teaching our community how to use AI on device. Edge Impulse is now a part of Qualcomm, so I'm also working with Qualcomm, and my background is in mobile from an earlier stage. So I have worked in Android, but back in the early days before you had all of the nice stuff like Kotlin and the Jetpack Compose. So it's just been refreshing to come here and kind of learn about where things have gone. So Edge Impulse and Qualcomm are more associated with embedded AI and performing inference on hardware. So I wanted to kind of show you how you can use our platform to build applications for running AI on device. So over the next 30 minutes, I'm just going to go through how to use our platform on the dev tier, which is free. You can build your own IP there. And the end of the product is an ML application that you can put onto the store and you own the IP for. So today's goal is very simple. We're going to build a visual anomaly detection system or a wearable on Wear OS that can detect an activity or that can detect a visual anomaly. So if there's been a defect in a product, for example. So let's get on to the next slide. So I'm going to show a quick video here, if I can get it to start, of what the visual inspection will look like here. So our repository is Kotlin based. That's where you're going to be doing your edits. It relies on the NDK, and we abstract away our C++ SDK, which speaks to the CPU, NPU, or device hardware to run the operations. And that just gives you access then to be able to build more complex AI applications on device. So this talk is just the starter. Tomorrow we're going to have a workshop as well where it's hands-on. You can clone the repo right now if you want to have a look through our Kotlin, and you can tell me how we can improve the AI, the UI, for example. I'm sure there's some areas there that we could learn how to improve. Definitely the compose features. I'm interested in seeing, what people do tomorrow with their example. So yeah, we're going to look really quickly at why you would want to run AI on a device, what Edge Impulse is. We'll have a quick look through the templates, and we'll have a live demo as well. I'll try and run some code on this Android test device and this Wear OS wearable. So I can go to the next slide. How do I go to the next one here? Okay, so ML, machine learning, is a subset of AI. AI is a broad area of artificial intelligence, including everything from your ChatGPTs to being able to run what we're going to look at today, which is ML. So it's associating previously seen inputs with outcomes. So when you see new data, you'll be able to build an application that's able to recognize that pattern again and do more complex applications than simple thresholding. For example, like when a temperature goes beyond a certain point, trigger a light if we were talking about a sensor. Accelerometer is what we're working with here today. So you'd be able to, for example, recognize a pattern of up-down motion. Well, you can't hear. You can't hear. Oh, okay. Maybe you can, there's the Wi-Fi app. I can ask them to maybe turn it up. Can you turn up the, okay. So you can't, can you hear me okay now? Okay. So AI is a very broad area, including everything from your LLMs, like your ChatGPTs, to what we're going to do today, which is ML. So machine learning, recognizing patterns and training a model that's able to recognize those patterns in future. So you're able to build an application then like a wearable that does activity detection, so you can count star jumps, detect when somebody falls, or for vision systems, if you want to be able to do some predictive maintenance, you want to do some, what we're looking at actually today is going to be anomaly detection, so visual anomaly detection. So it's trained on, we're going to see the example, you saw it running earlier, so you could see the squares that were being highlighted were showing where the fault was in the concrete. And then you're able to do something with that then. You could trigger an alert, or you could, like for the wearable, you might want to count. So I don't know if anybody's worked with Wear OS before. So Wear OS has this concept where you've got your app, which is your specific screen, but then you've got a thing called a complication. It's kind of like the dials that you have on the chronograph watches. So you'd be able to, let's say, count these activities like a step. Well, a step isn't that interesting, but let's say an activity like a fall. So if somebody in a care home fell, you want to be able to record that. And being able to do that on device is important because you may not always have connectivity. So what if that person fell and it wasn't connected at the time? You still want to be able to alert to it and trigger an alert. So what is Edge AI? I'm touching on it right now. Edge is from edge computing, devices that live at the very furthest point of the network. So like the likes of your devices at your home, like your laptops, your phones, your wearables, could be IoT devices. So although these models run at the edge, we still need to train them on the cloud. You're not really going to be able to train much of a model on a wearable, for example. And even if you were, it would kill the battery. So training it on the cloud still makes sense. That's where our platform comes in. But there's a lot of complexity as well involved in that. So there's a lot of tools that you need to link together. Anyone who's built an application, if you've been around Android, for example, for a number of years, you're going to see the progression as tools become easier to use. Like you've got your Gradles that came along that made build easier. So yeah, good tools are always useful. So our tool is a platform for building and deploying models. So this is a big paradigm shift. I've touched on this already, but so we're going from, on the left here, this is a Kotlin example that uses a threshold-based system, rule-based system, very simple one that uses a sensor that when you go beyond a certain threshold, trigger an alert. On the right, you can see that if we collect data that's able to predict all these different patterns, like these star jumps, these falls, or different daily activities, we'd be able to group them, and you can see them grouped here. Let's say green is a star jump, and on the right here, these are the falls that have been recorded or simulated. And then we can build systems that weren't previously possible. So there's many benefits. So if you've ever built an application before, notice that if you're very careless with the network connectivity, for example, you're going to run down the battery. So bandwidth and latency, two of the benefits. It's an easy acronym to remember. These is BLERP. So you've got your bandwidth, latency, privacy. So if you're making predictions at the edge where the information happens, like the falls, or if there's a medical use case, you don't want to be transmitting those types of images to the cloud. You can predict on the edge. It makes a lot of sense. Then efficiency, battery again, drain, cost as well, associated with anything to do with network services, your APIs. It's all going to cost money. And then reliability. You're not dependent on a network operator. So what is Edge Impulse? We're an ML ops platform. And we're a developer-first platform as well. We've got 200,000 developers spanning over 500,000 projects. And many of these projects are public projects as well. You've got two private projects that you can build on the developer tier, and then you can build an unlimited amount of public ones as well. So if you want to build something and you think that you might want to productize that in the end, obviously you want to keep that private. So we give you two of those, and we've also been ramping up the amount of training time as well that goes to our developer community. And I think we've got about 60 minutes right now. So you've got a wide community already, but we're primarily associated with embedded development. So hands up if anybody built for embedded before, the likes of an Arduino, for example. Yeah, Arduino, yeah. So definitely like Arduino, great place to start. They take a lot of the pain away from embedded development, memory management. I don't need to get into it, but yeah, if you're familiar with embedded development, it can be nebulous and complex, and there's lots of different IDEs. It's not as uniform as the Android community, for example. Okay, so our platform is fully accessible as well through APIs. So I mentioned that we're an MLOps platform. So if you already have CI/CD, or if you've got any form of knowledge on machine learning already, you can integrate and work with us through a Colab notebook. You can just pip install Edge Impulse, for example. There's a Rust API. We're fully integrated with the Qualcomm series of AI Hub APIs as well. And the output can be either a TF Lite model that you can use the likes of MLKit. You can use it with a C++, our C++ SDK, like we're going to see right now. You can run us on a Linux system. You can run us anywhere. And you can work with us in whatever language that you're comfortable with. Today, I'm going to try and show you the Kotlin way of doing it. So the end result here that we're looking for is the C++ library. And if you want to join the Edge Impulse platform, you can scan the QR code now and sign up. It's free. And if you want to see how to use it hands-on tomorrow, please join me. So you can grab one of our templates. So to get started with development, you're going to need to grab our repo, where we've given 3 templates, actually 2 templates, but a third one just got added yesterday by one of our community members around voice. So the 2 that I'm primarily going to be talking about right now today is the vision-based one, which is our anomaly detection on Android mobile, and then the fall detection on Wear OS. So, yeah. So this is the new tutorial that one of our community members with. We've got an active community, we've got a Discord, we've got our forum, which I manage, and then we've got an expert network of content creators as well, who are constantly creating new example tutorials that you can follow along. And once you sign up for an Edge Impulse project as well, you can, straight off the bat, you can build a keyword spotting project. So you can record wake words like yes, no, I don't want to say Alexa in case there's any devices here, but yeah, you can build your own version of that in 5 minutes. So you don't really need a lot of data as well to build a model. Like 5 minutes, I think about 8 minutes to build the fall detection data set. So once you download the repo, then you're going to need to populate it. So you follow along with the README. You're going to need to have an Edge Impulse project, which you've already trained if you follow along with the keyword spotting example. The output will be your C++ library, and then you're just going to dump it into the Android Studio project template. And this example uses our C++ library and the Android native development kit, which gives you the Android and Wear OS access to C++ features. So what that does is it abstracts away all of the domain knowledge that you need to have to be able to run operations efficiently on processors using the likes of the TF Lite library. Or if you wanted to work specifically with Qualcomm chipsets, the QNN SDK. So once you've populated it, and then I wanted to very quickly show you this is where the Kotlin fun starts. You've got your run inference function. So once you've got your run inference function working, the results then, all you need to do is pass a byte array or an image or a string of features from your accelerometer. So It's very easy. Anyone who's worked with a camera on an Android app before, I assume everybody knows it's just dot camera. If you want to change it to the accelerometer, it's dot accelerometer, dot gyroscope. Same thing goes for when you move to embedded with Android. All you need to do is just change dot, whatever the sensor is, like a PPG. If your project has been trained and built on that, you're going to be able to interface with it using our sample application here. You're going to see, once you pass the sensor data, you capture it as a bitmap byte array, pass it on to the RSDK through the Java native interface. Has anyone used the native development kit before for Android? No. So if you want to run a C++ library, that's where you need to install your NDK and then build a Java native interface frame class that can interact with it. So that handles all of the memory management and all of the pain that you typically would have had to do with a C++ application. So thankfully, one of our embedded developers, Dimitri, put all of this together so we can start with this as a template and build on it. So once we've got our defect that's been detected, we'll be able to control something or alert something, or for example, with our Wear OS, you'd be able to trigger a beep or an SMS using a service like Twilio, or using your SMS natively. So now I'm going to show you our platform. I haven't really shown it yet, but it's very intuitive, and it's very simple to walk through. I'm going to just grab one of the examples. So who here is more interested in seeing Wear OS, or are you more interested in seeing a vision-based project? So Wear OS, like a fall detection one, can I get a show of hands? Is anybody interested in Wear OS? Not a huge amount. What about the vision-based one? Okay, definitely more interested. Okay, cool. I'll grab the vision-based project. And I will try and mirror my screen if I can here. Okay, so this will mirror my screen. So here's where we start. Okay, where do we start? You're going to first start on this is the Edge Impulse Studio. This is our MLOps platform. So when you start off, you're going to need to get some data. So the easiest way to grab data is through your mobile phone. And you can upload data. If I can go back here. So go to the dashboard, collect new data. Okay, now I've got my QR code. So if you scan the QR code, and this is a dev kit. Let me just grab my proper phone. So let me just grab the slides here again for a moment, because I can see that I'm not going to be able to share my screen on this right now. So once you start to collect data from your mobile phone, you're going to see, when you scan the QR code, you're going to be able to see that you can upload data, and it can be labeled. It can be labeled up. No known here isn't very helpful. But when you're collecting the data, if you take a photo of a crack, for example, or a piece of concrete, you'll be able to label it then as a crack. And you can see the label data will start to appear in your project here. And we will give you a helpful tip here as well. If you're collecting data to your project, you need to reserve a portion to test your model against at a later point. So that's where you've got your test train split, and we normally advise 80-20. So if it isn't 80-20, you're going to get an alert here. let's go back to the project here. Okay. So now I've got my phone connected. I need to give my access to capture some images. I'm going to take a picture here. And we should see it appear. Okay, we can see that it's appearing. What is wrong with my camera here? Oh, right, okay. You can see it appears very quickly in your project here. So the mobile client is connected to my project. I can see what devices have been connected here. So I can see my phone. You can label it. So if you had many devices that are out in the field, the likes of, so this is where distributed teams come in. So if you've got engineers who are out in the field, you want to be able to collect data, all they need is the QR code. They can start to dump. You can share and collaborate on projects together. Our development team are remote based, so we all work remote. We can still work on projects together. I can work with the embedded developers. We can work with ML engineers, and you can see your project data set start to grow very easily. And then, so let's get to the next part of it, where we create our ML architecture. So we've got data that's been labeled. Now we need to decide what do we want to do with this labeled data? What kind of a application do we want to build? So this is our ML architecture. And I'm just going to delete these pieces here to show you how we can add them again. So the first point that you're going to hit is a processing block. You can see here that we've got a helpful hint straight away, a star next, because you've got labeled images. We can see that in the likelihood that you're going to need to pre-process these images, because it's labeled images. We're going to add that. And the next is the learn block. So what do we want to try and learn here? So classification, do we want to learn if there's a pattern that we want to be able to signal on in the future? So the likes of a cat was detected, or a dog, or a fall was detected, or a different type of activity. Then we can do different things like regression. So regression is like what we would use to be able to predict numeric values. So rather than predicting a label again, we'd predict the likelihood of another number in a feature set. So where this comes in is like if you've got a predictive maintenance use case, like a motor is starting to perform poorly, the numbers that are being uploaded to your data set or being seen by your model are starting to move outside the norm. That's where regression comes in. Then visual anomaly detection is what we were looking at earlier, where we've got a model that was trained on previously seen good concrete, and then anytime that we see a crack, then it's going to say, okay, this is an anomaly. I haven't seen this situation before. And that's really powerful, actually, because if you want to be able to build something like in a manufacturing, right, you're not going to know every type of defect on a product that can occur. You can simulate some of them, but there could be different type of defects that occur that you haven't seen before. So classification wouldn't work for that. That's where the visual anomaly detection comes in. And it's really powerful to see it working. If you come to our booth, you're going to be able to see this in action on a 5-year-old Pixel 3 phone using a very old version of the Snapdragon. And I went out walking with my son in the street, and we've like been inspecting the concrete, just looking at cracks, and it's like instant. And it's amazing to see it in action. For anyone who's worked with OpenCV before, I don't know if anyone's worked with OpenCV, but certainly in the early days, you're trying to run that on an Android device. The device is getting really hot as well. Like, to see how efficient these models run when you're using frameworks like TensorFlow is just amazing. So yeah, I'd encourage you to come along tomorrow if you want to get hands-on and build your own app. And the 2 templates that we have here, you can use in your own way and see what you might want to build. So there, we've got our model architecture that's been built. The next stage, classification, visual anomaly detection. Now we need to save this. So once that's been built and trained, it's going to kick off a job on our server where it's going to either use GPUs, depending on what you need to train, like how complex your model is. You might want to be able to get access to more training infrastructure, and then you'll get your result model. So I'm going to go back here, and we'll be able to see what we get at the end. Sorry, now I just want to change this to go back to the slides. Oh, it's extend display, sorry. Okay, so then once you've collected and designed your ML architecture, and you've tested it to see that it works, so you can connect your mobile device back and run the model on our web client on your device, and you're going to see how well it performs. You can test it right there, but it's not going to perform as efficiently as it would if you worked with the C++ SDK. So we need to do a final deploy as a C++ library. So I'm going to go back to my project here. I'm going to get one of the fall detection ones because I just want to quickly show you how we run our deploy. So okay. So I've got my droidcon organization, and I'm going to hit a deployment. Okay, wait a second. I need to go back to the different project here. Fall detection. So I want to very quickly show you how we can deploy. So once we've gathered all our data, trained our model, then we just need to select what we want to deploy. We've got a C++ library here. You can also, if you wanted to deploy to Qualcomm architecture, you can run on the RB3 or the Rubik Pi 3 as well. So we're going to deploy as a C++ library. So you need to select a TensorFlow Lite. We've got a Eoin compiler, it's called, and it reduces this for embedded development, but we want the TensorFlow Lite, so we just select TensorFlow Lite and kick off a build. Okay, so now a build is kicking off. So I've got a bit of a funny one here. So I don't know why that's not rendering. One moment. Okay, I can see it up here. Okay, so this kicks off the training job, and it's going to build and deploy our C++ binary. So once I've got that, just download the zip. So you just need to grab your resources then. The only thing that you're not going to take is the CMake list, because this is configured for an embedded device, and the one that's been included in the NTK example is already been pre-populated. So we're just going to grab these, go to Android Studio. Actually, I'm going to mirror my screen here because I can't see what I'm doing. Okay, so you can see Android Studio now, thankfully. So we just need to go into our app directory. So I've pulled the repo. I'm going to open this up. Go into your app, source, main, and in this C++ directory, you just need to dump in the downloaded folders. So I can see that they're in here now. And then I'm going to re-kick off a build here on Android Studio. There are the test cases. Here's the main Kotlin. So that's the inference results. So my run inference. So we start the camera service. Okay, I wanted to, so where you would want to change here, I wanted to very quickly show you. Yeah, so if you have any issues with the device that you deploy to, you may want to have a look at the width and height. So there can be, when you run this on a device that we potentially haven't tested on, you might want to reconfigure the resolution. That was the only issue that I noticed on the camera example. But then on the Wear OS one, you might have different feature length as well. But you'll get alerted to it once you try and run the project. You're going to get an alert, and it'll tell you, okay, you just need to change this value to you just need to adjust the feature length. So yeah. If you try and run this project, and if there's any issues with the resolution, just let me know on the forum. I'm on there the whole time, can help you out as well. Or if you have any ideas about projects that you might want to build using Edge Impulse, let me know. So I'm going to quickly go back to the slides now that we've kind of done an end-to-end very quickly here. So yeah, we can just very quickly as well look at some real world use cases. So for wearables, our two main pillars are human health and machine health. So the likes of human health could be your heart rate that you want to analyze. Machine health then would be motor health for predictive maintenance. But if you want to be able to run highly efficient models on industrial scale levels, you're going to need to move to embedded. And the beauty of starting with Edge Impulse is that you're going to have that C++ SDK that you will be then able to scale out to something like a wildlife camera that can run for 10 plus years on a coin cell battery. Or if you wanted to move to a high-end GPU for an industrial automation scenario, if you're running visual inspection on a manufacturing line, that needs to be split-second decisions for defect highlighting. Obviously, an 5-year-old Android device isn't going to cut it. And if you strap it to a tree in a forest, you're not going to get a 10-year battery either. So that's the beauty of starting with Edge Impulse, is that you're going to be able to get access to all of these native operators that exist on these embedded systems. So thanks for attending, and if you want to get hands-on with me tomorrow, please come along to the workshop. If you've got any ideas, I'd love to hear them. Does anybody have any questions about or thoughts about what they might want to try and build at the edge on an Android device? What? ML model, is it delivered to mobile application, mobile device? Yeah, it's on a binary. Sorry, the question was, is the model delivered in a binary? Yeah. So when you build it as a C++ library, you get a C++ library, and that's the binary that you can use. If you wanted to use it on a Linux system, you'll get it's called an EIM file. Oh, you can put your own ML model as well. How do you secure it? Okay. Yeah. Yeah, so the question was around security. I know that you can, so security will be up to the developer really. We have so all of the blocks that you saw today, they're very user-friendly and intuitive, but they're built by other teams. So the Keras block, for example, which is the ML one, or the deployment one, that packages the binary, it's all hosted on GitHub. So you're able to build your own block. If you wanted to add some signatures, let's say, for distributing that binary, you'd be able to incorporate it in. But
compromising of ML model, right?
Yeah.
We are building an application.
Yeah.
We just want ML model to be available, but we have trained a lot of things into it.
Yeah.
And we are worried about the leakage, the stealing of it, right?
Yeah.
The ML model from our APK.
Okay. Oh, I gotcha. Yeah. So the beauty about Android is, the question was, how do we secure the APK? And the beauty about Android is that it's distributable. You've got APK, you can install it on anything from like a Wear OS device to an automotive device to a phone to an XR headset. But how do you secure it? I guess signatures and obfuscation of the code, but we don't handle that part. We would be able to integrate with, if you did want to add some signatures, you'd be able to use your own framework for that, but that isn't something that we handle.
The signature is not about protecting the ML model. Signature is not about verification.
Yeah.
Right? We want to save our models.
Yeah.
So it's a very highly trained models. We have our data into it, and we don't want anybody else to get the models, right?
Yeah.
We want to have it only our app using it, not anybody else's competition.
Yeah.
That's a challenge right now.
Yeah, I think that's a big problem, and I think the only way that you can protect against that is really it's going to be
an encryption of it. Right?
Yeah, encryption.
It's huge decryption on mobile applications.
Yeah.
Mobile applications. It's a huge size. Expensive file though, but since 105 MB is file.
Yeah.
Right? And we try to decrypt on mobile application. It's a big size, it crashes the application, it causes a lot of delays and stuff like that.
Yeah.
So I was wondering if your platform does that.
No, we don't do that, but that's maybe I could follow up with you and I can speak to our engineers and see, what.
Where is the kiosk?
Pardon?
Are you
So we've got a booth over here. Just
the name?
the name of our booth. We're on the Qualcomm booth. Yeah. So if you want to talk to us, our sales and solutions engineers are at the booth. Yeah, for sure. And did you any other questions? But I hope that was helpful. Like, it's very easy to get started with it. I'd encourage anybody who's interested in starting with AI or wanted to build some knowledge on AI literacy, starting with ML and where it's really usable. You can see what's happening. You got your own data that you're loading up there. You're not relying on somebody else's models. It's a lot of fun. Yeah. Cool. All right. Thanks.